Καλησπέρα. Θα συνεχίσουμε στο δεύτερο κομμάτι μας της παρουσίασης γενικά για τα καύσιμα και θα εξετάσουμε τους τύπους των καυσίμων.
The learning objective of this chapter is that the learner will know the range of marine fuels which are available. There are a number of different marine fuel oils which can be used on board a ship. They can generally be classed into two groups, distillate fuels and residual fuels. Full details of the specification of both of these groups are given in the ISO 8217 Marine Fuel Standard. The source of these fuels and the characteristic properties are covered in detail in Seagull CBT Module number 179, Marine Fuel Properties 2. We will make reference to some of the properties in this module, but you should refer to Module number 179 if you need further information. The actual fuel being used will, to some extent, determine the components in the fuel system. As a general rule, distillate fuels can be used directly from the service tank, with only basic filtration needed, whereas residual fuels will require greater filtration, and will also need to be heated to control the viscosity at the point of final use. We will look at some of the common fuels next.
Βέβαια, όπως διαβάσατε και όπως ακούσατε, τα καύσιμα είναι πάρα πολύ σημαντικά. Βέβαια, έχουν φτιάξει και πιο μαθήματα πιο εξειδικευμένα. Βέβαια, αυτό κυρίως αφορά πιο προχωρημένες τάξεις, πρώτους μηχανικούς κτλ. Νομίζω ότι δεν είναι και τις παρούσες, αλλά και κυρίως δεν αφορά και τους δικούς μας μαθητές. Αυτά στην πορεία μετά από τα κεσέν ή από τις επιμορφώσεις που θα κάνουν να τα κατανοήσουν καλύτερα. Προς το παρόν, εμείς μένουμε στα βασικά για να έχουμε μια τουλάχιστον απλή κατανόηση γενικά ό,τι αφορά για τα καύσιμα. Είναι, πιστεύω, ενδιαφέρον, γιατί βλέπουμε κάποια πράγματα που δεν αναφέρονται ακριβώς στα βιβλία, δεν τα ξεκαθαρίζει ακριβώς.
Distillate fuels, strictly speaking, are those fuels obtained directly from the distillation process as a result of crude oil refining. Some of the marine distillate fuels are, however, blends of pure distillates and heavier fuel oils. The full specification for the 4 grades of marine distillate fuel are given in the ISO 8217 Marine Fuel Standard. DMX grade marine distillate is a high-grade pure distillate which is used only for special applications such as operation of emergency diesel engines. DMA and DMZ grades, usually referred to as marine gas oil, are also pure distillate fuels. DMZ is almost identical to DMA, but has a higher minimum viscosity. They are normally used on small engines, such as those found on tugboats and fishing vessels. Only simple filtration is needed before use to remove any dirt picked up during storage or transport. As with all distillate fuels, heating is not normally required. The last distillate grade, DMB, often referred to as marine diesel oil, is the distillate grade most commonly used by commercial shipping, usually as fuel for auxiliary diesel engines or for cold start of main diesel engines and boilers. DMB grade is essentially dirty marine gas oil with only a trace of heavy or residual fuel content. More thorough cleaning and filtration is required for marine diesel than for gas oil before it can be used in a diesel engine. Marine residual fuels are a byproduct of the refining process and are obtained from the residues of the various distillation processes. They are generally considered as low-quality fuels. There are many grades specified in the ISO 8217 fuel standard, defined by various physical properties, including viscosity and the type and level of contaminant content. Residual fuels require extensive pre-treatment before use. This will include heating to bring the viscosity down to an acceptable level. Residual fuels are commonly used for large 2-stroke and 4-stroke marine diesel engines and also marine boilers. Many auxiliary engines have now been designed to operate on residual fuels. Where the residues of the refining process are unsuitable for fuel purposes, then blending is often carried out to bring the fuel within a recognized specification. Click on the button to learn more about blended fuels. When a residual fuel falls outside of the accepted specification, it is not unusual for the supplier to modify some of the fuel's characteristics, usually density and viscosity, by mixing it with some distillate fuel. This process is known as blending. Although blending can result in a fuel which is acceptable and meets the requirements of the fuel standard, it can also result in fuel stability problems. A fuel is said to be stable if it maintains its characteristics during storage, treatment, and use. Sometimes a blended fuel will be unstable, and the different components of the blend will separate. This can result in serious problems, since the residual component may have characteristics which make it unfit for purpose. Incompatibility can also be a problem with blended fuels if the components react together, resulting in heavy sludge formation either during storage or pre-treatment.
Εδώ θέλω να κάνω μια παρατήρηση. Αυτό το σύστημα blending είναι λίγο παλιό. Ήταν παλιά η προσπάθεια των κατασκευαστών να μπορούν οι μηχανές να καίνε, που καίγανε diesel να καίνε και βαρύ με κάποιο τρόπο. Τώρα βέβαια οι καινούργιες μηχανές μπορούν να καίνε και πολύ βαριά πετρέλαια. Παρ' όλα αυτά, όπως καλό είναι να γνωρίζουμε λίγο την ιστορία, πώς εξελίσσονται οι μηχανές μας. Και γι' αυτό αναφερόμαστε εδώ πέρα.
Marine fuels often have some sulfur content, which, during combustion, can produce oxides of sulfur, SOx. Recent changes in legislation, in particular MARPOL Annex 6, have highlighted the need to reduce the SOx content of diesel engine exhaust emissions. The main focus in achieving this has been to place limits on the sulfur content of marine fuels. In addition, other authorities, notably the European Union, have issued directives or imposed regulations requiring much stricter limits for vessels operating in their waters. As an alternative to using these low-sulfur fuels, approved treatment facilities, such as exhaust gas scrubbers, are permitted, which reduce the SOx content of the exhaust gases. We will look at some of the issues related to the use of these fuels later in the module. Click on the button to learn more about low-sulfur fuel legislation.
Βέβαια, όπως καταλαβαίνουμε, εδώ μιλάμε τα καύσιμα χαμηλού θείου. Γίνεται πάρα πολύ κουβέντα. Βέβαια, τώρα που μιλάμε, υπάρχουν εξελίξεις διεθνώς. Μπορούμε κάλλιστα να ενημερωθούμε από το διαδίκτυο, γιατί καταλαβαίνουμε ότι κάποιες χώρες είναι πάρα πολύ αυστηρές σε αυτό το κομμάτι.
MARPOL Annex 6 has two sets of limits for the maximum sulfur content of fuel oils, one for general use and a lower limit for special areas, where sulfur oxide pollution has been shown to be a significant problem. Both limits are scheduled to be reduced. These special areas, known as sulfur oxide emission control areas, or SECAs, have to be approved by the IMO, and include the Baltic Sea area, the North Sea area, the North American area, and the United States Caribbean Sea area, with others under consideration.
Βέβαια, τα πράγματα έχουν ακόμα εξελιχθεί ακόμα πιο πολύ. Περισσότερες πληροφορίες μπορούμε να τις βρούμε στο διαδίκτυο.
Due to the rising cost of traditional fuels and the environmental impact of burning them, as well as concerns regarding future supplies, much work has been done with alternate fuels. Since these alternate fuels may require major modification to the onboard fuel systems, they should be mentioned in this module. The two main alternatives at present are gas from cargo boil-off and biodiesel. You can learn more about these by clicking on the buttons.
Αυτό που λέγαμε, τώρα έχουμε τα εναλλακτικά καύσιμα, τα οποία θα δούμε ουσιαστικά μπαίνουν σιγά σιγά στο παιχνίδι. Βέβαια τα πράγματα πάλι εξελίσσονται. Βέβαια εδώ θα κάνουμε μια παρουσίαση των καυσίμων αυτών, όπως ήταν βιοκαύσιμα, αργότερα η αμμόνια, το υδρογόνο προς το τέλος. Υπάρχουν βέβαια εδώ κάποια πλοία ουσιαστικά όπως τα LNG, τα οποία καίνε το φορτίο κατά κάποιο τρόπο, την εξάτμιση του φορτίου, του αερίου που χρησιμοποιούν. Καλό είναι βέβαια, είπαμε και πάλι, να μπορούμε να ενημερωνόμαστε, γιατί όπως βλέπουμε η δικιά μας η δουλειά των μηχανικών είναι μια δυναμική δουλειά, η οποία πάντα εξελίσσεται.
When transporting liquefied natural gas, or LNG for short, by ship, it is usual to keep the cargo at boiling point, which is approximately minus 161 degrees Celsius. This is achieved by using specially constructed and insulated cargo tanks. Even so, as heat leaks through the insulation, some of the liquid cargo flashes off as gas. If this is not dealt with, then the cargo tanks may become overpressurized and rupture. There are three possible actions that may be taken. Vent the gas to atmosphere. This is wasteful and harmful to the environment. Reliquefy the gas. This requires an expensive complex plant. Use the boil-off as a fuel to power the ship. This is the usual method adopted. Due to technical limitations, it was easier to adapt boiler combustion systems to gas burning than diesel engine systems. Therefore, most LNG vessels have been powered by steam turbines. The development of so-called dual fuel systems for diesel engines has resulted in an increase in the number of diesel engine-powered LNG tankers. Some new builds have either diesel or diesel-electric propulsion. We will look at dual fuel systems in detail later in the module. The current extensive use of petroleum-based fuels is the cause of great concern, firstly due to the rate that oil reserves are being used up, and secondly due to the environmental impact of burning these fuels. In an effort to find sustainable, environmentally acceptable alternate fuels, a lot of research has gone into developing so-called biofuels. Biofuel is usually produced from vegetable matter such as sugarcane, rapeseed or soya beans, and the product is mixed with petroleum-based diesel oil to produce biodiesel. Biodiesel mixtures containing less than 20% biofuel can usually be used in a diesel engine without any modifications to the engine. At the time of production of this module, the use of biodiesel in the marine field is mainly limited to the leisure sector, although there are efforts being made to extend this into commercial shipping. Some large diesel engines have been successfully tested with biodiesel, and a number of shoreside installations are being operated on these fuels. However, the current high cost and poor availability of biodiesel mean that it will be a long time before you are likely to have it as the main fuel for your vessels. In this chapter, we have looked briefly at the various fuels available for marine use. Although alternative fuels are being developed, it is unlikely that they will replace the existing fuels for some time to come. Strong environmental pressure has also brought about the development of low-sulfur marine fuels, and it is likely that future legislation will not only reinforce this, but also lead to lower limits for sulfur content. As we will see later in the module, this has already influenced diesel engine fuel systems and how we operate the engines. Try the questions and the following self-test to check your understanding so far.
Νομίζω ότι πήραμε μια γενική ιδέα για τα καύσιμα και τι μέλη γενέστε. Βέβαια, τα πράγματα έχουν εξελιχθεί ακόμα πιο πολύ. Οι προδιαγραφές είναι για την αμμονία και το υδρογόνο. Βέβαια, τα πράγματα ακόμα θέλουν πάρα πολύ δρόμο. Τώρα γίνεται ουσιαστικά μια δυνατότητα των υπάρχουν πλοίων με τα scrubber να μπορούν να επεξεργαστούν τα καυσαέρια. Και αυτά σιγά σιγά πιστεύω ότι θα μπουν και στα καινούργια αναλυτικά προγράμματα. Ήδη έχουν γίνει προτάσεις να μπουν στα καινούργια αναλυτικά προγράμματα, ώστε να παρακολουθούν και οι μαθητές τις νέες τάσεις της τεχνολογίας. Τελείωσε και το δεύτερο μάθημα. Σας ευχαριστώ. Καλή συνέχεια.